Hi, my name is Ao, and I'm a full-time systems designer. Over the years, I've been able to experience design systems from many different angles. I've been from advocating for systematic design at early startups to contributing to large design systems at software companies. So yeah, that's why I'm here. I'm here today because design systems have allowed me to acquire a unique lens for design. I've been fortunate to have mentors that have taught me how to connect the dots and the impact of design systems in technology. So that's what I want to share with you today. So far, you've become familiar with concepts and principles that define a good design systems. You've learned about the history and the influence and the motivations behind systematic design. I hope you feel inspired and ready to continue learning with a more hands-on approach. We'll talk about tactics, processes, and mindsets to become a great systems designer. But before we get started, here's a few things you should know. Design systems are a specific answer to a very unique problem. Going through this course, you'll have to think about hypothetical situations and examples so that you can understand how to then apply what you learned to the real world. In the next few lessons, we'll go over summarized examples of real-world design systems projects. But in addition, you can find extra material in the course resources. So remember, there is no single answer to a unique design systems problem. But by learning from real-world examples, you'll be able to acquire the mindsets and the ideas to apply it to your own work. So in this course, you can expect to learn about the following: how to be a better systems designer, what to focus on, how to think, how to document design system projects, collaborative processes and technical writing, how to create and develop design systems foundations, notions and exercises you can apply to early stage design systems, or even when starting your own, and how to design and flesh out a component for a more mature design system. So to learn all of that, you first need to understand what the hell is a systems designer. Not everyone in a design system team identifies as a designer, but there is definitely common ground for everyone who is contributing to a design system. Let's take a look. As systems designers, we often have to explain what we do for a living. People have come to me and asked me, what do you even do all day? Do you just play with buttons and colors? Don't you run out of stuff to do? Okay, thank you. There was a product designer once who told me, wow, your work is great. I wish I had the luxury to focus on the small things. Well, even though it sounded a little bit condescending, they were right. So think about it this way. Product designers work on very complex and linear problems, and systems designers create the material and build the material for product designers to solve those problems. So in order to make that material robust and scalable without jeopardizing the user experience and consistency, we need to allow ourselves to really deep dive into all the intricacies of these materials and apply systems thinking. So indeed, we do play with buttons and with colors. But making these elements easy to use takes time and deep systems thinking. So what is systems thinking, you may ask? To work in systems, it's important to learn about specific mental models. Systems theory is a fascinating but very extensive field of study, so we won't get into it in this course. But we will share some concepts to help you do your job better. We call these system thinking mindsets. Understand feedback loops. Feedback loops are recurring processes where outputs of a system circle back and become inputs. For example, a digital product releases new features that improve the user experience. That improved user experience causes better customer satisfaction. Better customer satisfaction generates positive feedback that attracts new customers. More customers means more money for the company, which enables them to hire more people so that they can build more features to continue improving the user experience. This is an example of a positive feedback loop.
but feedback loops can be negative too. For instance, poorly designed features can make the user experience more difficult, which causes customers to cancel their subscriptions. Fewer subscriptions means less resources available for the company, which means they might need to cut corners in their product development process, which might result in poorly designed features. When we're building a design system, we must understand how elements are interconnected so that we can create principles that result in positive feedback loops, like more efficient product development or more accessible interfaces. Embrace iteration. Feedback loops can take time to complete their cycle, especially when they're complex. So in order to keep the system moving and growing, we need to embrace iteration. One of the most common mistakes in design systems is trying to build everything at once in the beginning. Building a system with guidelines and patterns takes time, and a lot of knowledge we simply won't have until people actually use the system. It's actually better to start simple so that we can make the system available to designers early in the lifetime of a product. Make yourself replaceable. Ask yourself, would any critical information go with you if you left the company tomorrow? If the answer is yes, then you're making yourself part of the feedback loop, which means the system is unstable. Everyone who contributes to the system should be replaceable. And we accomplish that by documenting as much of our process and decisions as possible. This doesn't mean you'd be documenting yourself out of a job. It's about making sure the system is balanced and autonomous through closed feedback loops. Once you internalize these mindsets, you'll be able to create intentional design system processes and foundations for a solid system. One simple way to build these foundations is to start documenting your work from the beginning. So that's what we'll talk about next.
In the first lesson of this course, we established
Un sistema también es un acuerdo entre muchas partes. Es una suma de normas. Y como pasa con las normas, es imprescindible que se conozcan, se comprendan y se acepten por todas esas partes.
So in order for those rules to be understood, they need to exist first. In design systems, we say that if something isn't documented, it doesn't exist. Since the beginning of a project, creating documentation captures all your thoughts and decisions as they happen. This will help you prevent knowledge gaps. In this section, you will learn how to generate documentation from the beginning. We'll also go over some approaches and best practices to write technical documentation. The first thing you should think about is who your audience is and what answers they're looking for. In any organization with an operative design system, you'll be able to identify two main groups: maintainers and consumers. Design system maintainers are your peers. Anyone who contributes to the system can be a maintainer, and they can have many different roles. A developer may be wondering how to build a component that you designed. Other designers would want to find more information about the design process. And an external contributor may have designed a new component and they're wondering how to add it to the system. So in other words, any documentation for maintainers is internal documentation. It's going to be what is going to help other people continue your work. It doesn't really need to be polished, but it needs to be understandable. Any documentation is better than no documentation, but set some time aside to make sense of everything you're thinking at any point of the project. And create a source of truth about the project specifications. This will save you time not having to explain the goals over and over again and set context for your peers. And as a bonus, you can always go back to this document when you're feeling sidetracked or when you forget about the goals. Consumers are your customers. They are designers and developers who use the system to do their job. And some of the answers that they may be looking for are: where do I find this component? Is this component stable? How do I use this component? The design process can be very abstract. We rely on muscle memory and intuition. There's so many times I wish I had taken more notes or walked through my design process out loud or make a video or record it. We don't need to have all the answers right away. But remember, design is iterative and any documentation is better than no documentation. So in summary, documenting from the beginning is doing your future self a favor. So this is why we'll start with an exercise to create good design files to encourage documentation and knowledge sharing. Creating conventions for file management is critical to good collaboration. Because what we do has so many dimensions, there is so much work behind that just looking at a prototype or what exists in production isn't enough to set the full context. For this reason, a good file structure should be easy to navigate, be as visual as possible, and be mindful of performance. So here's how I organize my design files. Cover. First, I'll create a page for the file cover. And then I will add a frame for the title, status, and other project metadata. This page should help others find your files and learn where in the process the project is. Because we work in systems, we find opportunities to create standards so that we don't have to solve the same problem over and over again. If your team doesn't have a system for file management, this is an excellent opportunity to start. If you don't want to create your own, there are tons of resources you can reuse from the Figma community. Explorations. Then, we'll create a page called Explorations or Work in Progress. Your ongoing work will live there. Some tips to make this easy to navigate are using visual aids such as emojis, bullet points, or enumerations. Using dates can be very helpful to provide extra context. Other ways to organize your work in progress can look like this. It can be as messy as you want while you're working on it, but still, you should get into the habit of discarding duplicates and dead ends. Tests. This is the duplicate and dead ends box. This page exists to help you keep your exploration page neat. Having this page gives you the peace of mind that your explorations are somewhere recoverable. Be careful not to let it get out of hand though. If there are too many frames, the file will get heavy and slow. If that happens, just create an archive file for that project. Specs, also known as the development handover section. Even though tools like Figma and Zeppelin or Sketch have figured out solutions to smooth out this process, it still requires manual work. Luckily, you can also create a system for this. My system looks like this. Sticky notes for annotations, for example, to explain the behavior of an element or an unsolved caveat. Diagramming elements. For this, I use a Figma plugin called Autoflow. It makes mapping feedback loops and structures much more agile. Auto layout compositions for tags. This is very specific. I use these for projects where I need to establish naming conventions. The auto layout component allows us to make changes faster. We'll go deeper into creating specs for a case study in the coming chapters. And I'm sure this will make much more sense then. Docs. The Docs page is where your notes live. Future ideas and scoped out features. Think of this as the specs page, but for yourself. On this page, you can also start prototyping what your guidelines page will look like, because the decisions you are making are going to turn into guidelines. So we're going to talk about that next. Let's talk about how to write technical documentation. So what is technical documentation and why does it sound so scary? Technical documentation is basically a manual that you write for design system consumers so that they can use the system with confidence. In the course material, you will find my favorite documentation sites where I go for inspiration. Tips to get started with technical writing. 1. Don't be a wordsmith. Choose practical over stylish. 2. Use images and examples whenever possible. 3. Write simple sentences. 4. Be assertive. Remember, a good design system is commanding. And 5. Write first and edit later. So that's it for this lesson. We've covered a lot of concepts and processes that will help you be a better collaborator and also be mindful of your own process. In the next 2 lessons, we're going to zoom in into design system foundations and learn how to apply them to UI.